Hello. Right, let's get this underway. We'll see how this goes. Hopefully, the audio's all right. If there's any issues with the audio, please shout out in the chat. It should be all right, I think, at the moment. There's lots of new stuff on my desk at the moment, and I don't do this stuff very often. Anyway, right, let's get started. So, what are we doing? We want to write new pick and place machine software. What's pick and place machine, I suppose? What is a pick and place machine? Pick and place machine is a machine that comes along, takes electronic parts, and puts them on a circuit board. And that's one of the parts of the manufacturing process. There's many other parts of the manufacturing process, such as pasting the board before you put it in the pick and place machine. And then you've also got to put it in the reflow oven after you take it out of your pick and place machine. And before that, you've got designing PCB files, choosing components, ordering from suppliers, managing stock and inventory. And after you've reflowed your project, you basically have to do all the QA testing, putting it on your website and shipping it and everything. The pick and place machine is one small but very critical part to this whole process, as it were. So that's sort of like basic overview of what pick and place machine is and where it fits into the scheme of things. In a pick and place factory, you often get assembly lines which have got all these things in like a giant conveyor belt, and there's like hundreds of people running about making sure that everything works perfectly. That's not the target for this project, but we'll go into what the target is shortly. So let's talk a little bit about who I am and what I've been up to. For the last 10 or so years, I've been doing drone related things. So I started writing the Clean Flight software, which is probably still up on YouTube, on Tinternet. Yeah, there it is. Look, still going. Pro map, it's a bit out of date now. This project aimed at taking an existing code base and knowing that the person that was running this code base didn't know everything, and knowing that lots of other people did know lots of things. And also at the time I was into clean code and all the various different development practices around that. This is quite a long time ago now. This project was wildly successful in that it brought together lots of people from all around the world and helped to make awesome drone software. And that spawned off two other projects on the back of it, which are basically the pretty much de facto standard software that you'll find on any drones that are running. And as part of that, I also started making flight control boards because there weren't ones that I liked. One of the ones that I made was the SP Racing F3, which was about 2015 or so now. Yeah, it's a good 10 years or so ago now, coming up. And there's some history about all the different products and so on the SP Racing website. And some of these boards have been manufactured by factories over in China, and other ones I've made myself in more recent years. And I was able to make them myself because I bought a pick and place machine. And it was this one, in fact, from Charm High. And, if you look online, you'll see various people saying, yeah, it's not bad, but the China software is not great. And it's true, it isn't great, and it doesn't really fit into the workflow that you need, which you don't really know that you need when you just buy a pick and place machine to try and assemble some products and get things shipping yourself. But it's a sort of trial by fire if you just buy a pick and place machine. And it has a touchscreen user interface, very tailored to the specifics of the machine. And it sort of works all right. It's got some annoying things on it. Its accuracy is not fantastic. You learn to work around the quirks of the machine over the years, but it's not a fantastic machine, but it is a usable and workable machine. And I was using this for quite a while, and it's been, it's been fine. I was able to make nice little circuit boards like this kind of thing. Here's one, is a recent one, an Express LRS one. And it's also able to make little teeny tiny little circuit boards like this. I'm not sure how much light there is in here at the moment, so it might not come up. Anyway, there's one. So, it was able to make some circuit boards. It was pretty good. And then one day, I'm like, I had enough of the machine and its quirks. And over the years, people have been saying, put OpenPnP on it. So I'm like, all right, today's the day. So I disassembled the machine and put new cameras in it that I bought 5 years ago, reflashed the control board with SmoothieWare, which is the software that you have to use on it. Took out the touch panel because OpenPnP needs a desktop machine, bought a desktop machine, connected everything up, and started using it. And, well, yeah, it left a lot to be desired in a number of areas for me and my use case. It's not to say that OpenPnP is bad software or anything like that. It's in fact very good software, so I want to be clear on that, because some people might think I'm dissing OpenPnP, but that isn't the case. It is good software. It just doesn't work for me and how I want it to work. And if I want to contribute to it, the way that I have to contribute to it and the things that I have to do to contribute to it also doesn't work for me. So the idea now is to write new pick and place machine software using more modern technologies. But before we go into that side of things, I want to quickly talk about who this project and the software will be targeted at. So the target audience is not like a factory with hundreds of pick and place machines. They can afford lots of people to run around and look after the machines all day and sit there setting up job files and all this kind of thing. It's not for that. It's for makers and very small, sort of 1 or 2 people, that kind of size outfits that just want to make stuff, but in sort of low volumes, not high volumes, because the moment you go to high volume, it doesn't make sense to do all this yourself because you just outsource it to a fab. There's this sort of sweet spot with a pick and place machine which makes a lot of sense. Some of the sweet spots for me involved reusing lots of components on a few varieties or different boards, such as making 3 flight controllers of various different sizes for various different applications which have a common set of parts. And if I was to order from a factory like 500 of one, 500 of another, 500 of another, that's a massive outlay. And if there's problems with any one of those designs and it fails, then you've got loads of stock on hand and you've got parts that you can't use and it's too risky. So one of the things that a pick and place machine allows a small outfit to do is de-risk their projects. So I can go and buy products like components at their volume pricing. So I can buy 500 MCUs, for instance, and then have a bunch of different projects which all use the same MCU. So I get the economies of scale at the pricing level, and I avoid the overhead and setup costs that you would get if you, and also initial upfront cash requirements that you would have if you wanted to take each of these 3 designs and have a fab make them, because you have to make loads of PCBs and you have to have setup costs on a per project basis, and then there's loads to it. So it allows you to de-risk making a few small things. So if you buy like common components like, say, some ESP32 micros, and you've got an idea for a few projects that use the same, then it's great. It works really well for that. It also allows you to do just-in-time manufacturing. So instead of having to make all of your products like up front and just have them ready to ship, you just make like 30 at a time, which is fine. You can get that done in a day with a pick and place machine, even on a 2-sided board. And then you've got stock there waiting to sell, and you've not used your components. And if you need to make changes to it, to the design, you can do that. So it's a sort of essentially a quick way of going from prototyping a product into actually having the final product out there. And the prototypes end up being exactly the same as the final designs. Yeah, and I mentioned a moment ago about de-risking the failure. So if one of the projects isn't very good, you've not wasted loads of money, which is very handy. And the target audience is also for someone who values their time for creating rather than babysitting pick and paste machines, because they do need a lot of babysitting. Well, at least the Charm High one that we're looking on the screen does. So with the Charm High one, for instance, it might fail to pick up a part, it might fail to do this, that, and the other. You've got to sit there and watch it all the time. I thought I'd be able to just press the button and just have it go. I mean, that's what you want, but in reality, that doesn't often happen with this machine as it was. So let's see. Next. Other options considered. So, other options considered. This is a fun list. Improving OpenPnP. I decided against it, but I'll come down to that in a minute. Porting OpenPnP to Rust, because I like programming Rust. No, because of the issues with the PnP codebase, such as favoring old Java practices because it's written in Java. And it would certainly not be idiomatic Rust if I was to choose Rust as the language. Outsourcing my manufacturing. Yes and no, but I already have a pick and place machine. I already have all the component stocks, and I already have all the things that I need to do what I'm doing. So I don't really want to just stop this and just outsource everything to manufacturing. Giving up entirely was another option that I considered. Just for a caution to do and just do something else instead. Well, sort of that's what I did with the manufacturing. I've just given up on my manufacturing for now. Because of the impact that changing my machine to OpenPnP had on my workflow that I mentioned earlier, because the pick and place machine is just one small part of a larger machine, as it were. So yeah. So I don't know if there's any other software developers listening to all this, but I don't know how many of you know about contributing to open source softwares. But when you contribute to a bit of open source software, you create what's called a pull request. So you go onto GitHub. We'll just randomly show you the Clean Flight project on GitHub. Here we go. So the idea is I would fork the code, make my changes to it, and then do a pull request and say, here you go, here's some changes I've got. Can you merge it with your code? And in order to do that, you have to look at the code base, decide what needs changing, and hopefully it's got some merit in it. And then you sit back and you wait. And some projects, you can be waiting quite a while because the developers and maintainers are asleep. Other times, they don't even get a notification. Other times, they don't understand what it is you're trying to create. They don't understand why you're trying to do it. They might have their own ideas about how things should be done, and so on. And creating a pull request and working around a project is like going for a software interview and then also a job interview for a software development, and then getting there and the first day in the office, and you're like, I'm working on this bit of code, and you're just like, I wouldn't have done it like that. But you're just like, nope, not saying anything. I've got to wait. I've got to, maybe it's okay. Maybe it's okay. And then you work on a bit more stuff, and then you're having doubts, and it's only your first day. Doing pull requests is a bit like your first day on the job. At the end of the day, or the end of a couple of days, you've got to decide whether you still want to work there or not. For me, I looked at the OpenPnP code base. I submitted pull requests. I talked to the developers a little, and they have mailing lists and so on like this. Not in great depth. I think most of my opinions were formed by looking at the code base and deciding that I don't want to work there and that I should do it myself. And there's a bunch of reasons why I thought that. Let's bring up the OpenPnP code base for a moment. Where are we? OpenPnP code base. Right. This is the OpenPnP code base. And yeah, I mean, I started running these tests just before the live stream started, and some of them are failing. It's been going 18 minutes so far. Scripting tests are failing. I'm running out of Java heap space, but you know, I've got my heap space set to 8 gig, and there must be something else going wrong. If you run this separately, it works. Anyway, it's not a great feedback loop. So one of the things that there needs to be in a project for me is that you run the tests and it fairly quickly tells you if everything's okay or not. So okay, fine. So the feedback loop, not particularly great. Testing, the approach to testing that OpenPnP has is not the same as what I would prefer. There's a lot more weight given to integration tests. So for me, there's sort of like a test triangle. We can probably open Paint and draw a little thing. This is fairly sort of common. This stuff is. So you got a test. Oh, that's the wrong tool. Okay, it's orange now. No, dear me, that one. Click brush, draw in orange. Here we go. Test triangle. So at the top you got functional tests, integration tests, and unit tests. And you're supposed to have a few of these ones, so not many. And then you have lots of these ones. Lots of these ones. And then integration tests sit somewhere in the middle. And it's problematic to have lots of functional tests because there's pros and cons of them. They take ages to run. And they break easily if you make a change somewhere, and they're hard to maintain and they require lots of dependencies. Unit tests, on the other hand, only test a teeny tiny little bit in isolation from everything else. So if you only had unit tests, you wouldn't know when you put all the things together the whole project would still work or not. So you have lots of unit tests, but they're nice and fast to run, and they test the tiny little detail, like, I don't know, you've got an input box and you want to make sure that the strings on the end of it, the white space is trimmed on it, right? But if you fired up an entire user I had some code which typed some string in that had white space on the end and then validated it at the end of it, it would take ages to do that because you've got to spin up the entire UI to do it. So it's expensive to do it like that. So you don't test things like string trimming in your functional tests, but you do that at the unit test level. So after looking at the OpenPnP code base, the triangle that I see is like this. It's sort of like that. There's basically not many unit tests, and there are quite a few functional tests. Additionally, there's great swathes of code which are not tested. You've got two main chunks of code. You've got the machine and you've got the UI. The UI's pretty much got no tests for it whatsoever. This does have some tests. So if you wanted to make changes to the UI and make sure you've not broken anything, there's no tests for it. You've got to write your own tests first. Good luck in doing that. So yeah, so I didn't fancy that. You know, these were all my first day on the job thoughts, kind of thing, as it were. So yeah, replace active suites. There we go. Code coverage. I want to quickly talk about code coverage. So I've just run all the tests, apart from the odd one or two that failed. And I look at the things that I wanted to change for my machine. I wanted to change some stuff to do with feeders. And I look at the feeders and I look at the coverage reports for feeders, and it's only 8%. Now, you don't rely on coverage reports to say that your software is working. That's not what coverage reports are. But you use coverage reports to gain confidence in changing certain areas of code. So for instance, if I look at the coverage report and see it 8% for the feeders, I have very low confidence that if I was to change anything in any of this feeder code, that my machine would work properly. So that's how I'm using the coverage reports. Whereas if I look at, say, I don't know, we can look at the driver code, for instance. You know, G-code driver seems like there's pretty good coverage over here, which is good. So if I wanted to work on this, hopefully if I change something and it broke, a test would fail somewhere and it would tell me about it. So the approach to testing is one of the things that irked me. One of the other things that irked me is the user interface. So as I mentioned, my pick and place machine had, if I can find my browser window again, yeah, my pick and place machine had a touchscreen user interface on it. This is its touchscreen user interface. I'm not going to go through the whole video. I'll put links there later anyway. And it has a touchscreen interface which is operator friendly. So, and I specifically bought a machine with a touchscreen user interface on it so that I don't have to have a separate PC on all the time, because I didn't want to have to maintain yet another desktop machine, because you need Windows updates, you've got no, didn't want to deal with that. I just wanted this little self-contained thing that just does what it does and is a tool. It's like a hammer, an expensive, complicated hammer. So, what was I getting to? So, user interface, yes. So, touchscreen user interface, OpenPnP. Let's bring up the OpenPnP user interface. Here we go. Let's just run this. It won't take a moment. Here we go. So this is what you get if you've just run it for the first time. And you get this. And this user interface, I find it confusing, unintuitive, and odd. Okay, I'll just go into a bit why I find that. So there's different types of people in the world. There's people that are academic, and they can be really amazing at things that are sort of like, I don't know, how should we say, like, okay, let's just say that academically orientated, and there's other people which learn a different way, and the academic people, they often learn by sort of reading and processing information and then coming up with their thoughts and so on based on this information that they've learned. I look at things and learn things in a visual way. I'm what's called a visual learner. So for me, I like my software intuitive. And this is one of the reasons why I don't use KiCad, for instance. KiCad for me, I mean, you guys are going to have a laugh now. Here we go. This is me trying to use KiCad for the first time. KiCad 8. We're just going to go test, and we're gonna do something really simple. Okay. We're gonna try and draw a box in KiCad. It's KiCad. Right. I want a PCB outline. Okay. I've never used this before, so this will be funny. So we've got to find the PCB outline. Schematics. All I want to do is draw a box for the outline of my PCB right now. All I want to do. can't see it. I've got 3D viewer, updating PCBs, checking design rules. Yeah, you kind of all need all that stuff. What's over here? Logical footprint traces, holes, build zones, rule area, draw a line. Here's a box. That was me trying to draw a box. Oh, you click. Oh, and then you click again. You see, my first attempt was just a total failure. I clicked and dragged. You see. Right. Yeah. Okay, I've got a tool. I suppose. Do I click this to get rid of it? Okay, now we're gonna just resize a box. So maybe we have to select it. Yeah. Okay. Okay. Fine. We can resize boxes. Okay. Fine. Not too bad. Okay, let's try drawing a trace. Finish. We've drawn a trace. Amazing. I'm trying to zoom in now. There we go. Oh, yeah, there we go. Now I'm going to try and edit a trace. Anyway, I'm not going to get too far into this. But my preferred PCB design software is DipTrace. Because to me, as a visual learner, it has a more intuitive interface. Drawing a box. Yay. Clicking on it. Moving things around. Drawing a trace. Yay. Coming back to the trace later. Moving it around. Now, granted, I've been using this for ages, but it didn't take me that long to figure that out when I first used it, and I liked it. It's got a very usable interface. So, going back to pick and place software, I want my pick and place machine software to have a nice user interface which is intuitive. The Charm High VB48 machines software, because it's touchscreen, it's fairly hard to have a non-intuitive touchscreen interface because it has to be intuitive if it's the touchscreen user interface. Some things, you might look at the buttons and just go, what does that mean? Because with a touchscreen interface, you can't hover over anything because there's no hover, right? With a mouse, people say, hover over it, you'll get a tooltip. With the touchscreen interface, it has to make sense, like at first glance, without having to hover over an element for it, because you can't hover over it. It has to make sense. And this is how I want my UI. So one of the aims for this is making a interface which works intuitively. So that's high up there on the list. Other things that made me not want to contribute to OpenPnP, we'll go back to it. We'll just go back to the source code for a second. Let's have a look-see. So it's a Maven-based project, Java Maven-based project. And it uses lots of Java technologies. Now, I used to do a lot of Java technologies back in 2010 and before. And, it was all right back then, but, that's like 14, 15 years ago. I remember the first book on Java version 1. I had a book, Java, it said. It didn't say Java 2 or JDK 8 or whatever, like it's Java. Just Java. So I've been doing Java quite a long time. And there's a lot of good code out there that's built up over the number of years. But the problem with it, because it's been around so long, is that some libraries are built using one programming pattern, other code is built using another programming pattern, and the language itself and its standard library has been added to and improved over the years, but the developers haven't updated their libraries to use these new modern programming practices. So you can be pretty much guaranteed that all of these dependencies will have completely different programming styles within each of these dependencies, which is not ideal if you want to make changes to one of them because of issues with it. Lots of these dependencies are out of date. For instance, the Jython one only supports like Python 2, for instance. So there's lots of very legacy dependencies. OpenPnP has been around for quite a long time, and a lot has changed since the project was created. So I don't have the real desire to work on stuff that I was doing about 15 years ago using old technologies and old programming patterns. So that's another reason why I don't want to continue with it. Yeah, it's approach to testing, operator friendly. Yeah, I'm just looking at my list of things. Yeah, one of the other things that really hit home to me when I upgraded to OpenPnP. It wasn't an upgrade for my workflow. So as I mentioned, that a pick and place machine is only part of the problem that you're trying to solve. It puts the components on the boards, great, but there's a lot that needs to happen before that. So, for instance, in your EDA tools, let's see if I can just open one up, just so that people have an understanding of where I'm coming from with this. Resize that. There we go. And we'll just open up a recent design. Oh yeah, it's because I moved it. Okay, hold on. Jeez. I reinstalled Windows 11 on the machine the other day, so lots of the files are all in the wrong places. Right. So, as some people watching the live stream now might know, I've been doing work on Express LRS receivers and flight controllers and so on. So this is a schematic for the RX-N1. This schematic is available online now because I'm not going to be manufacturing these anytime soon, so I thought I'd just share them with everybody else. Anyway, in the schematic, let's just have an example of some components and see what you do. So you're designing stuff. If you're in schematic land, you're not thinking about pick and place machines. You're not thinking about anything like that. You go, I want a circuit. To make a circuit, I need some components. Component selection and circuit design is a large part to this project. Component selection is, if you're doing a new design, is one of the things that takes the most time. So choosing which component to use. For instance, I made an LED board recently, and it must have taken me about 3 hours just to find the LEDs. 3 hours, because you've got to go price, availability, technical specifications, and all the rest of it. And eventually you settle on one. And ideally, you don't just settle on the one, you have to settle on a couple of alternatives in case one of them becomes out of stock. So then you've got to find 3 things that you could perhaps put there in place of it if one does come out of stock. So then you've got to go comparative specifications and so on. And then you've got to look for, well, are they all in stock? It's a nightmare. Component selection, nightmare. So eventually you settle on 3 things that might work. So at that point, I bring out the paint. Got paint. It's so bright. Apologize for this. Oh, there we go. Right. So at this point, you've got in your schematic. Let me change the color. You've got a part, right? And it's in the schematic. It's a logical part, right? And then you've chosen 3 physical parts. Right, you've got A, B, and C. You've got, let's just call this X. And essentially, there's a mapping between a logical part and physical parts. Why is this mapping important? Because when it comes to ordering components, and having a BOM. So a BOM is basically what you get. Can we look at it here? Let's export. Let's export a BOM so that we can see. So we've got name, manufacturer, quantity. Let's add name, part, add value, and ref days. Okay. Let's see if we can just place the table. Okay. I don't normally use the tables for it, but for today's exercise, everything's fine. Let me just move this around so we can see it. So we've got a BOM, right? And we've got values, and sometimes you might have parts in the case where there is only one specific part. But other times, you don't really care that you're going to use this MC0402B103K160CT 110 nanofarad 0402 6.3 volt cap. Other ones, some other manufacturers would probably be absolutely fine. So this is where you've got a logical thing in your EDA tool, in your BOM. But when the pick and place machine has to put something on the circuit board, and when you have to order things, you have to order the physical things. Right? So OpenPnP doesn't care about any of this. It doesn't really care about any of the workflow that you might require for doing this. It has a concept of parts, and I can't change the name of the part, which I find really weird. You can't right click it, you can't left click it, and there's nowhere to change the name of it. You can add new parts. You can go 0402 cap 10 microfarad. Right? But if I made a typo there, I can't change this. And then it's kind of got weird things on it. I'll come into how it doesn't work for me a bit more. Anyway, so this is OpenPnP's concept of parts. Right. Let's go back to this. So you got parts. You got physical parts. Physical parts are mapping. And then you've got orders, which is where you go to supplier and say, I want some parts, please. Thank you very much. And then you've got stock when they arrive. And the orders and the stock don't care about the logical parts in your schematic. They care about the physical parts. So inventory management basically is what we're dealing with as part of this. Let's bring up here we go. Inventory management. All right. So inventory management, there's open source solutions to allow you to define a product and define all the parts that make that product and have them in one giant database. And then for KiCad, for instance, there's integrations with various different inventory management software solutions which allow you to use those parts in the KiCad and other tools directly. So the idea is that you can create a product. I'm not an expert on inventory yet. I had a tinker with it. That's about it. So you can create parts, electronic parts, for instance, connectors and whatever. And then you can create stuff called assemblies, and assemblies use the parts that you've ordered. So you basically need integration between your schematic, your inventory management system, your pick and place machine, and how many of those parts that it used to go back to your inventory management system and update the remaining stock. So OpenPnP doesn't have any of this built into it at all. And honestly, it's not the remit of OpenPnP to have these exact features. It's more inventory management rather than picking and placing. But the way that you have to interact with OpenPnP, to me, seems sort of inverted, because OpenPnP is the master of truth, essentially. As in, you define your parts in OpenPnP, as opposed to defining your parts in your inventory management system. So what I'm thinking is that you need to be able to have something which takes your bill of materials, runs it through some form of assembly variant, with an A. Let's call this Z. And Z might use part A. And A comes from this part in the schematic. Probably should have used different colors for that. There we go. That's how they're related. And then Z might use another part called Y, which has other physical parts, say D, E, and F, which is Y, and Y goes to these. And the assembly variant will use, let's call this ZZ. Oops. Let's go ZZ. And ZZ is going to use, oops, wrong one, wrong color. ZZ is going to use part B, which comes from Y in the schematic. So there's this whole mapping thing which goes between it. So in order to build something, you've got to go, well, what physical things do I have now in my collection of electronic components and reels and everything, which ideally is listed in your inventory management software. So you have to go, well, okay, to build this schematic, what parts can I use to build it? Because maybe you bought the one LED, but now you can't get that LED and it's out of stock anymore, but you've got some other one instead. So you've got to build a different assembly variant to use the new LED that you've got. And so that once your pick and place machine has built all this, you can then have it tell you how many it used, so that you can then update the stock. Yeah, so part of the workflow. This part of the workflow is what I want to help improve for everybody. Because at the moment, doing something like this, it's a bit of a mess. It's such a mess that I decided that there was no sort of hope in fixing it within OpenPnP in a timely manner. Yeah. So because of that, I paused all my sort of manufacturing operations, and I'm just going to fix this problem. Yeah. So yeah, that's part of it. Workflow integration. So that's covered that topic for a little bit. Architecture. Hey, let's go architecture. Oh, here we go. This is going to be entertaining. Let's resize that. OpenPnP's architecture. Yeah, I went through some of it, looked around it, and this is what I saw. This is as it is today. Excuse the poor quality of my, writing stuff here. But anyway, it has a main frame. It has, which is, let me see if I can just highlight these. It has a main frame. It has configuration. It has a machine. It has actuators. It has a motion planner. there's things called motions, and there's a bunch of other things which I haven't dug into in massive detail. It's not too important. So you go, okay, well, configuration. You're like, wait a minute, There's a lot of things in here. Interesting. So let me bring up the source code. Where's my IDE gone? There it is. Okay, so let's look at configuration. Let's bring up the structure. I find this is IntelliJ that we're using here. I find that the structure or outline view in Eclipse is a good way to navigate around the important methods, classes, and so on in a project. So, you've got files, you've got some packages, and the packages combined with the structure of a thing, it's a good way to sort of have an understanding of how things are laid out. So I open up configuration and I look at its member variables. And you're like, okay, interesting. Okay, well, yeah. And then you have a look at the structure and you're like, configuration. Well, to me, I've got a configuration. Great. I load it, I save it. Let's look for load and save. There's configuration. You can create a configuration. Great. With a file, with a directory. Seems reasonable. Good Lord, there's a lot of things here. That's more than I was expecting to see. Load. There it is. Load. You can load configurations. Great. Okay, let's look for save. Save. You can save a configuration. Great. Okay, so you've got a configuration. You can load and save. What else has it got in here? Let's have a look. Parts, panels, loading up things from configuration. Yeah, this seems fairly reasonable. And what else have we got in here? Let's have a look. Set length display format. Set locale, set machine. Wait a minute. Set machine. Who owns the machine? Configuration owns the machine. Yeah, okay. And then you start wandering around looking to see where things are. My first thought on this configuration class is that it's doing way more things than configuration. It's also providing, and you can see that from this, it's actually providing like a central place for services. It's so machine is a singleton, and instead of asking machine get machine or get instance or whatever like this, you ask the configuration to get the machine, which is weird because I expect to be talking to a configuration thing about loading and saving and serializing and deserializing and asking for a setting or something like that, right? So this seems odd. So a lot of these things feel like they shouldn't be here. Sure, it could load and save them, but whether you want to be able to do other operations on these without going through configuration, so yeah, it's kind of weird. Yeah, and it's got loads of stuff to do like units. And then it's got these things: scripting and event bus. And again, it's sort of scripting and configuration. Really, it's just odd. Like this should be its own thing. Event bus should be its own thing. They shouldn't live inside the configuration. In my head, this is how I think about it. Mainframe. This didn't seem too bad. It's all UI stuff basically. It's got the kind of things you'd expect. It's got panels. This is sort of like more what I would expect. When I open up a mainframe, I want to see like all the subcomponents of it and layouts and all this kind of thing, right? So this kind of stuff's okay. And then if you delve deeper into it, you find drivers for interacting with control boards. So the way pick and place machines work is that they generally have a control board which is dealing with stepper motors and vacuum sensors and fans and blowers and pumps and encoders and all this kind of stuff. And this is all low-level real-time stuff. And then you have the high-level code, which is sort of like make the control board do what it needs to do in order that the machine moves around. And this is just sending commands to it. And G-code is normally how these things work. So if anyone's done anything with 3D printers, you'll find that there are a couple of bits of software. There's essentially 3 bits of software that run a 3D printer, and it's similar in pick-and-place land. You've got your slicer, which is essentially your sort of like job planning. And then you've got your thing that runs the G-code and interacts with the machine, and you can poke the machine around and move the head up and down, left and right. You can preheat the bed and all this kind of thing. And then you've also got the control board, which actually runs the G-code. Sometimes those last 2 things are part of the same one system, but there are still sort of 3 distinct elements to it, as in you've got a operator interface, you've got a planning interface, and you've got machine hardware control. So these are the 3 things. Pick and place machine is similar to that, except that you've also got the workflow to contend with as well, which is a little bit like your slicer, but it has to talk to other things as well, and it has to get results back from the pick and place machine. With a 3D print, you press print, you let the machine go and do its thing, and it either works or it doesn't. And at the end of it, you've got a 3D print, which is a physical thing, and you don't have to go and update stock in an inventory thing apart from the thing that you've just made. You don't have to say, well, I used all these components and all this kind of stuff, which you have to do for a pick and place machine. Additionally, with a pick and place machine, unlike a 3D printer, mid-job, you might need to change your plan. So, for instance, what can happen with a pick and place machine is that you're building something, you've told the job to go, it's using a feeder to put a component on a circuit board, but somehow your stock count was wrong and you run out of parts, or maybe it mispicked a bunch of them and it's run out of parts, and now you need to get a new reel out or load more parts into the machine, and then you've got to reconfigure the machine for the new reel because they might be on a different side of the machine, or there might be slightly newer components, or there might be an entirely different component, but you still need to finish that job before that job is done. So pick and place machines are weird in that you need to change things mid-job. So this has impacts. It has big impacts on the software and how it's all architected. Right, a little bit about that. Other reasons why not to improve OpenPnP requires a JVM, which is fine for doing cross-platform stuff, but unfortunately it doesn't even run on the latest JVMs, which isn't ideal. Many of the dependencies were out of date. I covered that a little bit, but there's so many that are out of date, it's nuts. And then when you want to add something new to it, such as, I don't know, an HTTP server with a REST client in it so that you can talk to it and add parts to it, for instance, which is one approach I thought about. It turns out you have to update a load of other dependencies in order to add this new dependency or new feature to it, and then you have to start touching way too much old code. And before you know it, it's like a massive change, and then the maintainers are never going to accept it. The maintainers might not even understand why you want it in the first place. And if you've not got assurances that your changes that you need, that specifically that I need for my tasks, if I haven't got these assurances that my changes are going to be accepted, then my alternatives are fork the project entirely and don't bother passing any of the contributions back upstream, or not use it, which is a little bit tricky because you're trying to run a business still. Where are we? Yeah, odd design things, Java-y stuff. Let's have a quick look at a feeder for a moment. Oh, no. Reference push-pull feeder. So various packages, various different design patterns. Java technologies have this inheritance, and so does a lot of C++ rather. So reference push-pull feeder extends a reference feeder. Reference feeder extends abstract feeder. Abstract feeder extends abstract model. Okay. That was a lot. Okay. Yeah. Okay, so let's just have a look at that again. Abstract feeder. An abstract feeder implements a feeder. So there's the interface for the feeder, right? So there's a lot of inheritance going on. A lot of inheritance. And inheritance has there's good points and bad points about it. But with modern practices, the approach is composition over inheritance. So you have something which has a property, and then you ask it to do something, and it delegates that to one of its properties, or it uses something else. It doesn't try and do it all itself. It isn't all of these things. Oh yeah, feeder. Look at it. Identifiable, named, wizard configurable, property sheet holder. So a feeder has got sort of UI topics and ideas built into the concept of a feeder. And this to me also seems very, very wrong. A feeder is, something that feeds parts into a machine. And then you've got a UI which should create a feeder. It shouldn't be part of the feeder. That's how I see this stuff. I may be wrong in some of this stuff, but this is how I'm finding it. So if I look at the reference push-pull feeder, for instance, there's these wizards that go along with it. And the reference push-pull configuration wizard is this. And we can see where this is used. So the feeder itself asks the UI to give it the wizard. It just seems inverted to me. Inverted. So I don't want to unpick all this inversion. I don't want to go through fixing all these odd arrangements of code. So configuration to me seems like almost like a util class. And I don't want to have to go through and unpick all this. It would take too long. It would break loads of things. There aren't enough tests for me to have any assurance that doing it might actually work. I've been through all this once before with, many times before, but on a large project with no tests. And it's not a fun place to be. You spend a lot of time fixing things, and a lot of things break, and it's massive changes. Just ask Timecop about CleanFlight, and I'm sure he'll tell you. Oh dear. There's differences of opinion on how things should be organized and why and so on. There's for me, there's just so much that I want to change. I haven't read through much of the chat. I will do that at some point. But today I'm just sort of trying to get all this out there. Anyway, so OpenPnP. It's not very modular. It doesn't support the things really that I want to do. Oh yeah, one of the other things. These three things, in fact, are just deal breakers for me. It's got null checking everywhere, like everywhere. Null checking in 2024. Turning null. No. Return result objects and use optionals. But the entire code base is written like this, and it's 10 years old, and changing it all and trying to fix it. No. So yeah, result objects, null checking, favors inheritance over composition. Don't like it. Yeah. Okay, so enough about OpenPnP. Right, that's OpenPnP. And again, I'm not slating OpenPnP. It just doesn't fit for me. It's not written the way I would write it, and it doesn't do the things I want it to do in a way that works for me. It might work fine for other people, and that's fine. They can carry on using it if they want to, but it's not for me. Goodbye. Right. So, given that we're not porting OpenPnP to Rust, we're not working on the OpenPnP code base. We got to figure out something else to do. So I've been doing Rust programming, embedded Rust programming, for a couple of years. I've had a 6-month break, so when I get back into it in the next few days, I'm going to be rusty. No pun intended. Yeah. Also, I was doing embedded stuff, and therefore I wasn't using much of the standard library and so on like this. So let's talk about Rust for a minute. Why Rust? Here's Rust. If you want to learn about Rust and what its goals and aims are, you can have a look on the website. But basically, it's a nice language to use. It supports lots of modern language features, modern sort of API features and programming paradigms and all this kind of stuff. It's also got an extremely, extremely high quality library of existing code. Now, if you compare the libraries and the dependencies of other languages, such as, say, JavaScript, Python, C, and Java, you will find that those languages that I've mentioned have all got various different programming styles that have been built up over different years, and they've all got different ways that each of the different libraries and dependencies that you might want to use work. With Rust, because it's a newer language and it's built on a newer set of principles, it's aligned the minds of so many people when they're creating new software, which shows in the quality of the libraries that are available to be used. However, a lot of these libraries are very, very new. So there's quite a few bleeding edge things which you have to deal with. But sometimes dealing with a bleeding edge thing is better than dealing with 10 years of legacy garbage and bloat that you don't want to touch. So with software development, everything's a compromise. So there's loads of really good crates. Tokyo, event-driven application programming is great for networking. There's just so many. Serde is one for serialization. And if you just want to find just random things, I don't know, CSV parsing, and you can look at the stats on these things as well, which is an interesting way of looking at how popular something is. And then we've got other things such as, I don't know, Google Sheets. So we've got integration with Google Sheets. This one's not used very much, but I think there was a new one, Sheets 4, this one, and you can see that some of these things are more popular than others. But there is a vast library of quality dependencies which can be used. And additionally to all this, Rust has also come up with standardized ways to do documentation for all this. The Java ecosystem has the Java APIs. The Rust has that, but it also has what's called books, and they're all in a very similar format and similar veins. So if you want to search for something, you normally find there's a book on something. So for instance, Rust embedded book, right? And they have this kind of style, and there's loads of these. So lots of library authors create a book on how you go about using it. What I've often found with Java APIs is there's not very good sort of introductions and walkthroughs on how to actually use the API. I'm finding that somewhat clear in Rust ecosystem, but not totally clear. Yeah, so it's got excellent standard library with support for things that we know that we're going to need. It's got excellent support for collections, streams, maps, lists, things that in other languages weren't done initially. So, for instance, Java literal map syntax. Oh, Java literal Stack Overflow. 16,000, well, 1,600 people have asked how to do it or looked at it. That's because it's not built into the language. So you have to go and ask some random people, like, how are you supposed to do it? How? Other languages have better support for collections and maps and things like this, Rust being one of them. Yeah. So it's got a great standard library. It's got nice support for threads, concurrency, and all this kind of stuff, which is not too bad in Java, to be honest. But in other languages like C, not so great. Python, not the best choice. C++, again, not what I want to be doing in 2024. Portability. Rust is fairly portable as long as your dependencies are also portable. So you can write Rust on a desktop machine, you can write it for embedded stuff, you can write it for Android stuff, and so on. And it's mostly nice to develop in until you beat your head against the brick wall that the compiler shows you when you're talking about the borrow checker. Everyone gets stuck with the borrow checker, myself included. It's a learning curve. But once you work it out, and I'm not saying I've worked it out completely myself, then it's definitely better. But it changes how you think about how you develop your code. So, let's talk about architecture of what I want to build. So the architecture for me, and this is first thought. It's probably going to change over time. But I'm envisaging some sort of machine thing. With a job processor, and so on. And then some sort of UI for planning. And then some sort of UI for operations. How these things are all going to talk to each other at this point in time? How these things are going to talk to each other? Like what's, how do you go from here to here? Don't know. How do you do it? Don't know. These are all things we're gonna find out as this project progresses. We're gonna evaluate different ways of doing things and go from there. And then of course with this planning stuff, and you've got the machine, somehow you've got something else as well. I'm not sure whether it's part of the UI planning, and this is the integration with the inventory systems. So let's just say inventory up here. So where the boundaries are, not entirely sure at this point. Like, should the machine feed the stock counts directly back into the inventory, or should that go as some job result into the planning software, which then exports it to the inventory? Don't know yet. We're going to try and figure that out, but that's sort of what I'm thinking anyway. So then it's like, well, what are we going to write all these things in? Yeah, what are we going to write them all in? So just bring this up for a moment. So it feels to me, and there's a few ways that we could do all this. The UI operations, I definitely want to be touchscreen. So I want to have a small screen on a pick and place machine, or maybe it's a large 19-inch monitor mounted on the wall or something like that above it, but certainly touchscreen to interact with the machine. Whether the UI planning software is also touchscreen, I don't know. Because what I've found in the last 5 years or so of manufacturing stuff is that you essentially want a nice environment with simple to use controls, and you're very often cross-referencing lots of things, and because of that you don't want to be walking over to the machine, hitting some buttons over there, coming back to your desktop machine, hitting some buttons over here, and then having the two things talk to each other. I don't think that's sort of where we want the UI for the planning side of things to be. I don't think that necessarily needs to be touchscreen interface. It might be, but my first thought is that that's probably some form of desktop app or Android app or something like that. Probably desktop. But I don't know yet. I've got 1,000 thoughts going around in my head, as you've probably all gathered by now. So, general architecture, not going to go into it too much. A lot of these things will fall out in the wash when we get there. Goals for the system, I suppose. Fixing issues as they occur quickly. That's definitely one of the things that we want to be able to do. With the Charmhigh pick and place machine software, let's see if I can bring this back up again. Where is it? Here it is. This thing. With Charmhigh pick and place machine software, you would essentially use these buttons down the bottom
placed at an XY
to make modifications to your job, and then you could resume the job from the last component that it placed. That worked pretty well. So it has to support being able to make mid-job changes, be able to fix issues as they occur. So common issues that occur is failure to pick, blocked nozzles, problems with vision, for instance, like maybe the sun came out and now it's affecting the cameras on the machine and so on. Stuff like that. It happens. I've already mentioned integration with the inventory system. Repeatable tooling. This is one of the main usability things, as I mentioned in this. And where's my other little diagram? And this. So there needs to be a repeatable process which takes in an EDA file and goes through the list of parts and so on like this, and then works out what you can place. So that to me seems like part of the UI planning. So if we write EDA integration. Right. And this probably talks to this. I could do like 2 hours. Here we go. EDA integration. That's where that sits. It doesn't, that stuff definitely has got nothing to do with the machine whatsoever. It's very important. And this needs to be repeatable. So the process that you often find yourself going through is in your EDA tool. Let's just bring up a schematic. Right.
in your EDA tool, you'll find you'll have placed a component and you'll have given it some name, value, I don't know, loud, right? And then you'll have exported your BOM and you picked your assembly variant based on the fact that it said loud in there. You know, maybe there's some rules to say if you want a loud loudspeaker, you use this part. If you want a quiet one, you use this one. And then one day you decide that you need to make a change to your schematic. So you come back to your schematic after having assembled things. You come back to your schematic, you change your values in here, and then you re-export this, you update your PCB, and then you've got new pick and place machine export files from your PCB design side of things. In DipTrace, these are created by doing this, and it gives you a CSV file. But before you do that, you import the updated schematic. And then that gives you a pick and place export file with now, and then it'll have a different value for the component that you changed in your schematic. And then the idea is that you would then go back to your EDA integration bit of code, which probably also talks to the stock control to work out what parts you have got, so that you can come up with an assembly variant in the planning. And it's quite common to realize that you've got typos in your schematic or whatever, and then you go back to your schematic, or you've got the value of it wrong because you copied and pasted a capacitor into the wrong place, and then now you've got to update your board files. But you're never changing the Gerbers at this point. You're literally just changing the logical representation of the components in your schematic. Or maybe there's some other thing that wasn't quite right in your schematic, and you've just got to come back and change it for whatever reason. So this needs to be very repeatable. It also needs to be very quick and not intensive. Another thing that needs to happen, panelization. Panelization. So when you're building circuit boards, you use your EDA tool and you make one part. I'm just going to open up an existing design. If I can find them, here we go. Open up this. Here we go. Right. So this is one board. Now, panelization. EDA tools support making a panel in the EDA tool, but that's not the only way of creating a panel. Other ways of creating a panel, for instance, is to go on to the website for your PCB fab, such as JLCPCB, and then go in. I'm not affiliated with them yet. Right, what am I doing? Instant quote. Where's the quote thing? Oh, yeah, that's what. There it is. Right. Other ways of doing panelization is you get your fab to do it. So panel by customer is where you do it in the EDA tool, and panel by the PCB fab is this option. So you say, I want 6 of these designs on a board, and then you get a panel with however many there are on it. This is in fact the Flight 1 Lightning H7 board that I designed. Get rid of that. So yeah, panelization. So why do we need to know about panelization? Why do we care about panelization? Right. So the way I do it is I get my PCB fabs, whoever they are, to do the panelization. I say I want a board with X amount on it, and I know that there's various constraints on the routing, like if you've got a part overhanging the edge of it like a USB connector, then you need to tell them, no, you can't do V-cuts, you've got to leave a hole there, and so on. But it's normally a fairly simple process. You just say leave a 3mm gap between it, put the mouse bytes on the corner PCBs here, and put the fiducials in the corners and put the label on top. It's fairly common stuff. But how does that impact our workflow? So great. So now you've asked the fab to do the panel. Right. So you don't have any machine files yourself with the fiducials on it or anything like that. All you get back from the fab is the Gerber files after they've put your design, moved it around a bit, rotated it perhaps, put the fiducials where they are, and then so on. And you end up with... I don't even know if I've got Gerber Viewer installed now. Let's have a look. I'm going to reinstall my machine. I do have Gerber Viewer. Okay, we're okay. Everything's fine. Everything's fine. Here we go. Gerber Viewer. Resize that so we can see it. Right. Yes, and this is a weird app with an odd dialogue, so we're going to have to find the path. This one. Manufacturing. JRPCB. Manufacturing files. Okay, is what they said. Right. Yeah. Right, here we go. All right. So what you get back from manufacturing is something like this. So in your EDA tool, just to refresh your memory, you've got this, which is the design for one board. And then your PCB fab goes, here's what it looks like with 10 of them on it. This board is so small that you need to make a certain amount of them. Otherwise, you can't even fit it in the pick and place machine. Because the rails that hold the PCB can only go, they have to be a certain distance apart, which is wider than one PCB. And also there's overhead in making single PCBs versus making the panel of PCBs, such as applying the paste, setting up the job, making sure all the parts are all there. If you do it for one at a time, it's more time consuming than making, say, 10 at a time. That's because of the overhead. So panelization allows you to reduce your overhead. So you want panels. But unfortunately, I don't have any panel definition. There's no panel definition. It's not in my EDA tool. All I've got is Gerber files. So what I've been doing for the past X amount of years, and I hope to improve this, is some way of displaying the Gerbers in the planning software and pulling out the locations of the fiducials and the dimensions of the panel within the software itself. Currently, what I've been having to do is create little script files. Let me see if I can open up a new IntelliJ thingamajigamy. What I've been doing is where is it? Manufacturing. PnP convert. Here we are. I totally trust my own code. New window. Just do it. Right. So what I've been doing, and we'll open up the panel definition for one of these, is defining a panel in code. Well, as I say, command line arguments, essentially. And then I have a piece of software called PnP convert, which has been an integral part of my workflow for a while. PnP convert, this thing. So I've archived it because I ain't going to work on it anymore. No. Rest in peace. So what this program does, it takes the pick and place machine file, what this program did, I guess it still does, it takes the pick and place machine file that's exported by your EDA tool. Let's see if I can find one. Yeah, I suppose I've got one here, haven't I? No, not that one. Wait, wrong window. This one. Yes, it takes one of the pick and place machine files, which basically has like the reference designation, name, pattern, where the part is located, the center of the part, which side of the board it's on, how it's rotated, the value of it, and so on. And it takes that, and it takes the information about how the PCB fab made the panel, which has got various different dimensions on it. Let me see if I can find. Yep, here we go. Yeah, so this is essentially the job file. So this basically says use the CSV file that's got all the information in it, then use the definition of the panel, and then use the definition of your machine, and then build a file that I could upload to the pick and place machine. And it would build this file from the pick and place machine using my, I don't have Chrome installed, using a spreadsheet which basically contained all of the definitions of my components, my feeders, and all this kind of stuff. And it's this which I want to bring into the architecture for this bit of software. So let's draw another box. Let's draw a green box. Panelization. Panelization, yeah. So UI planning. Probably like that. Let's save this as a... Don't really care. Let's go PNG. Projects. Architecture overview. Fine. Right. So I want to bring that stuff into this as well. And as we can already see, there's a lot of work going on here, and we've not even talked about how to actually make the machine move or anything like that at all yet. Good lord, this is a large project, which hopefully is becoming apparent by anybody that's still watching. Hi, if you are. Right, yeah. So, good lord, lots of things. Let's talk about target platforms. Target platforms, hardware choice. What are we going to run this code on once we've written it? If we're writing it in Rust, we can run Rust code on Linux, Mac, Windows, Android, embedded stuff. Some things don't make sense really to run on embedded stuff, and there are various software constraints as well. So one of the other things that's not on this list yet is this blue box over here, which is going to have the word vision written on it. And this is an interesting box because it has great impacts onto the choice of hardware that you need to use. So for pick and place machines, they generally use two cameras. One goes on the head, moves around with the head, and then the other one points up from the bottom and looks at the component that is on the nozzle. Let me see if I can bring up the list of pictures of pick and place machines. Here we are. So on these machines, you can see there's various cameras on them. So for instance, the one I've got, it's similar to this one. It's got a camera at the front, and then it's got a camera on the head. other super crazy fast machines, they might have like 8 cameras and 8 nozzles, and they bring like the head up and it's got 8 parts on it. It takes a photo of each one, and then all the nozzles move around a little bit, and then it puts all the parts in the right place before it goes over to the feeders and picks up 8 more parts. But initially, and also remembering the target audience, we don't need to support crazy machines. Makers aren't going to be having crazy machines. The pick and place machine factories are going to be having the crazy machines. So we don't need to worry about that yet. We are mostly dealing with 2 camera machines: down camera machine, up camera machine. A machine with up camera and down camera. So vision. So clearly the machine, when it's running a job, it needs to look at the vision. So there's communication between these things here. The UI and planning, there is likely going to be communication between these as well, such that you can set up your feeders and all this kind of thing, and mark the position of where things are on your machine. And in order to do that, you need a camera. Whether it goes through the machine job to get the information from the vision system, or whether it talks to the vision system directly, I don't know yet. We can work it out. So yeah, vision. So you need 2 cameras. 2 cameras. 2 cameras. Going back to the hardware side of things, what's it going to run on? So let's have a quick look at 3D printer control boards. Now, 3D printer control boards are 10 a penny. There's loads of them. Commonly, they have support for X, Y, Z axis. They often have X, Y, Z, and then an extruder as well. And these are all normally driven by stepper motors. They also have MOSFETs which control bed heaters and extruder temperatures. Pick and place machines, on the other hand, don't have extruders, but they often have peelers instead, which need more axes. So they have the X, Y, and Z. Thanks for that. And the X and the Z controls the nozzles. And in some machines, there's multiple stepper motors for the nozzles. So they sometimes have a stepper motor per nozzle. Other machines have like a cam arrangement where they have a single head which has a single stepper motor, and if it turns in one direction, it moves one nozzle down and the other nozzle up. And then if it turns in the opposite direction, it moves the other nozzle down and the first nozzle back up again. But they're on a cam, so they never go too high. And there's lots of examples of machines like that. So you've got, on a pick and place machine, you've got X, Y, Z, possibly 2 Zs instead of possibly the second Z is where your 3D printer's extruder output might be. And then you also got a vacuum pump. So in order to suck a component up, you need a motor on it, which is a vacuum pump. And then in order to let go of a component, what they often do, they have just an air pump essentially, which goes through the same lines as, or rather, it switches the air going to the nozzle from a suck to a blow. So it has there's basically an actuator that you need which can do that. So it's either on suck or it's on blow. And they need to be fairly fast acting. And they're normally just triggered by a general output from a MOSFET or something like that. So 3D printer control boards have some of the things, but one of the things they definitely do not have is vacuum pressure. Now, in order to know whether a part is on the end of the nozzle, you need, let's go back to pictures of them. There we go. You need to be able to detect the airflow on the vacuum line. the vacuum pressure, basically. So there's pressure sensors. 3D printed control boards don't have that. They also don't have cameras or camera switches and things like that. Some machines that are out there have 2 cameras and a camera switcher board. So you only have one input to the computer via USB for the camera. And it switches the input from one source to another source. This is very common on the cheaper machines. It's cheaper to have like one chip and like a video switcher than it is to have 2 capture switches. Plus, there's also implications for the amount of USB ports and streams and all this kind of stuff that you have. So camera switches or 2 cameras is another requirement. And in order to operate a camera switcher, you need various GPIO outputs and so on. So normally one 3D printed control board can't handle a pick and place machine. You have to get the fancy ones, and even they don't have support for the vacuum sense lines, for the vacuum pressure. So one solution to this is to buy 2 cheap 3D printer boards and then have another board which has the vacuum sense lines, or to buy a dedicated board which just basically has everything. The machine that I've got, which used to be on my desk behind me, but it's not there now. There's a CNC machine there right now. My pick and place machine is hiding in the other room because I know I'm not going to be touching it anytime soon, even though I'm writing pick and place machine software, which is fun. So that machine has obviously its own control board. I should have some photos of it. Yes, it's probably worth me bringing that up now. Let me see if I can find the URL to that. Give me a moment. Didn't have this one prepared. My bad. Yeah, here we go. Right. So these are all photos of the machine that I've got. That's how it came, without some of the feeders attached to it. And it has a control board inside it. We'll have a quick look at the control board so that we know what we're dealing with. This control board doesn't have onboard stepper motor drivers. They are separate. So inside the machine, let's see if we can find it. Yeah. Yeah, here they are. So it basically has these, and these are the stepper motor drivers. There are boards which exist, such as the Oculo board, which you can get, which has all of these things on it. There we go. I think there's a newer version of this which has stepper motor drivers on the board itself. So this basically has all the things you need to run a pick and place machine. And there's a few other options as well that are out there. But most of these boards, they all run G-code. So for the architecture of the system, it basically means that you need to talk to one or more control boards. Control board. Like this. 1, 2. And the only thing that is going to talk to these control boards is the thing that's running the jobs. So if you want to move the head of the machine over from your UI operations panel, right, it goes through the machine job, and then the machine job goes, well, you know, the Z-axis is on control board A and the Y-axis is on control board B. Probably wouldn't set it like that, but there you go. That's what it would need to do. So it would need to orchestrate your desired movements on the control boards that your machine needs to use. That's a fairly important part of the architecture. Definitely need to support multiple control boards. And it might be that one control board runs G code and the other control board has another completely different interface to it that's not even G code. It could just be something extremely simple like a UART protocol which says turn on vacuum pump and turn off vacuum pump. It could be like that. The point is, we don't care about the communication protocol that's being used, just that there needs to be some form of abstraction there. Right, so yeah, so going back to the hardware to run all this, you could imagine a fancy control board such as the Clipper boards. Let's try and bring that up. Clipper boards. Now these Clipper boards. Is it there? Let me see if I can find. It's probably easier if I look for photos. No images. Clipper. Here we go. Yeah, here's one. So a Clipper control board has a Raspberry Pi like add-on to it. So they run the stepper motors and all that kind of thing from the main board, and then they have another bit of firmware which runs on the Raspberry Pi, as I understand it. So that's one sort of solution for doing the, and then you could obviously attach like a touchscreen display to that. So that's one sort of solution for doing the machine and the operator controls side of things, which would be UI operations, machine job, control board. But then how do you adjust like your feeder setups and things like that mid-job? Because that needs to talk to the planning thing, really, because the planning stuff is where you'd be setting up your feeders, probably. So, yeah. Maybe. Another option would be to have a single board computer running embedded code. My first thought is I'm not a big fan of that potential solution because of the vision side of things. The vision side of things has implications for the hardware constraints of any single control board. Plus, it also pigeonholes it a little bit too much. This is what I think. So I'm not sure about the single board solutions. So I think for me, sort of like the combination of some desktop app, some touch UI app, and some control board is probably what will work. Running the machine operations and some of that on an Android tablet, for instance, or something like that, or an Android single board computer might be okay. Android has support for multiple cameras. I was looking through the APIs recently. There's the, let's have a look. Not that one. Yeah, this one. Android Camera X API, which has been around for a while, and this allows you to use multiple camera streams, which is required for this. So running some of this on Android is an option. Might be doable, don't know yet. It might be nice for people making machines because then they can ship it with an Android tablet, which obviously has got all support for like decent UIs and capable UIs, and it's also got touchscreen and things like that built in, versus like a desktop machine with say Qt on it with a independently attached touchscreen monitor. Might be another way of doing it. Right. Okay, we're going to pause here for a couple of minutes while I nip to the loo. Back in a jiffy. Alrighty, we're back again. Okay, let me have a quick look at the chat and see if I can just do a bit of question answering if there were any questions. Rabbit, glad you like the sound waveform. Yeah, I thought that was a good idea too. Boss drama incoming. Not looking forward to that. We'll see. Yeah, academics. Yeah. Easy EDA, intuitive, interesting. Yeah. Altium Designer. I didn't get on with Altium Designer or Eagle. They're almost like too much like CAD software from 30 years ago. They're weird. Concept of like having a tool rather than just being able to use a mouse and just move things around and do stuff. Making PnP software. Here we go. One thing Commander Guy asks, one thing I've been wondering since you've started this project, are you planning on making MakerPnP software work on OpenPnP, LumenPnP hardware, or do you want to roll your own board straight away? So as I just was talking about, we'll go back to the architecture little diagram thing for a moment. This thing. So as I was mentioning, it's like I don't care what control boards people want to use; they can use whatever they want to use. So yes, ideally it should run on a bunch of different boards in the same way that OpenPnP currently runs on a bunch of different boards. I don't want to be rolling my own board straight away. My goal initially is to get my manufacturing back up to speed again, because my workflow was broken by my upgrade to OpenPnP. And I don't want to put the machine back as it was for the reasons that I went to OpenPnP in the first place. And I don't want to use OpenPnP for the reasons that I've already discussed in the video. So my only alternative is to write my own pick and place machine software, which does what I wanted to do for my workflow. And that means using the stuff I have on hand initially. And then ideally, and I haven't talked about this much yet in this, and ideally attracting other developers to the project that want to code in Rust, that have similar views to how things should be tested, and so on, can just help out with the project, because I know that I don't know everything. I know there are large gaps in my knowledge about many different things for this thing. But sometimes it's good to throw yourself in the deep end, and you never know where you end up. As I mentioned in the Discord, channel, on the Discord server or in the general channel, there's a guy on it's called Not an Engineer on YouTube, and he says just start. In a couple of years, who knows where you end up? And he's talking about CNC machine lathing and stuff like this. Completely different thing, but the principle is the same. Start, never know where you end up, and you're going to get out of your comfort zone, and there's going to be things which you're going to need help with. But I'll work that out as they come. I don't need to do everything to the same level that and the same degree of accuracy, for instance, that OpenPnP currently can do things, and it's got support for some very advanced features which have taken clever people a long time to come up with the algorithms and solutions for. And what's good about OpenPnP is that all the details about certainly how the code works is there, and some of the detail about why the algorithms exist and how they came about can be found in like discussions and so on. So you can use that as a reference to work out, oh, these are the problems they solved. This is how they solved it. Is this useful for us? Yes, we can use the algorithm, not the code, the algorithm, in this project if it makes sense to do so. Other things it might not make sense to do so, and we certainly don't need all of the different things that it can do straight away. It just needs to work and be able to assemble PCBs and have the workflow I'm more interested in getting the workflow right and then improving little bits of it as time progresses. But the workflow is the thing that I think will make the difference between what I'm trying to create and existing solutions that are out there. I mean, you can have a look at, say, for instance, the Neoden software. I think I've got that around somewhere. YouTube. I think I bookmarked it. Playlists. PnP software.
This video is going to be
Is it in this one? No. Neoden 4. Yeah, this one. Mute that. So in here you can see how the Neoden 4 software works. And it's sort of very similar to the Charm High software that was on my machine. So, but again, this doesn't have any integration with workflow. At least it's not evident from this tutorial video that they posted. It's like, this is how you set up the machine, this is how you put all the parts in it, and then they go to the part where you assign parts to feeders and stuff. I'm just like, oh, it's the same. It's the same. It's the workflow isn't there. That's what I've been seeing between existing things that are out there. So, right, let's have a look, see if there's any more questions. Multi asks, how are you going to handle dependencies like when you select an alternative part, you also have to update some resistor value? Yeah, I think I already talked about that earlier. Where I want to have it so that it's easy to come up with assembly variants, essentially. Let's have a look. Yes, Commander Guy notes that fixing all that is going to take just as long as making it from scratch. Yeah, this is what my thought was as well. Stream. Oh, Rabbit Ambulance doesn't buy him a loo break. Yeah, I've got to go to the loo. Coffee break. Yeah. Oh, yeah. Might be a beer break next time. Let's have a look. Right. Okay. Okay, no more questions. I think we're getting through this now. It's not. Yeah, my list of stuff on my videos coming to an end. So hardware, yes, talked about that. Talked about this. User interfaces. It's been keeping me up. This has been keeping me up. This has. What to do about user interfaces. So Rust is fairly new, right? Rust. So if you go use Rust UI, and there's coincidences in this world are just fantastic, right? Best and easy GUI for Rust in 2023. You're like, okay, let's read this. Yeah. So there's a few things that come up. And I was doing a bit of Googling the other day. And just remarkably, what I stumbled across was this. Which, people that know what I've been up to recently will chuckle at immediately. Hold on. We're not looking at the right screen, are we? There we go. Gyroflow. Right. This is hilarious for so many reasons, right? Because Gyroflow uses black box logs. Just the coincidences are abounding. It uses black box logs plus a video to create smooth video. What is a black box log? A black box log is one of the key features. Oh dear, it's just hilarious. Clean flight black box log. Oops, I typed it in wrong.
But anyway, one of the first features that made CleanFlight so useful and that I knew would be a game changer was to accept the pull request from Nicholas Sherlock for the logging system. And that is basically what enabled CleanFlight and other flight control software to have such good flight performance, because it was able to very clearly and capture everything that was going on the drone as it flew around. So that was a key turning point. So Gyroflow uses black box logs, which were initially created by Baseflight and CleanFlight, which are projects that I was involved in. Why are we looking at Gyroflow again? Well, let's go look at the GitHub. So it's written in Rust. Okay. It's written in Rust. Here's the cargo file for it. Fantastic. Why are we looking at Gyroflow again? Because we started talking about user interfaces. What interface does Gyroflow use? Gyroflow uses, and the astute among you might have already noticed other things in my title bar, these little green icons up here. Oh, I'm on the wrong camera again. Hold on. No, I'm not. We're on the right one. OHC, it's just offset just slightly. There we go. Right. It uses Qt. So Qt is a cross-platform. It's a bug in my room. Cross-platform UI widget framework with pretty decent tooling, and other people that I know, that I trust, other developers that I've been working with for a number of years. Even my ex-girlfriend, she used to write code in Qt because she said it was good, and other people who I also trust as developers have also used Qt, and they've said it's good. I have not used it ever, so it's going to be a steep learning curve. But it has nice things. It's got a bunch of widgets. So my first thought, well, it's not my first thought, but my current thought is to use Rust wrappers around Qt in the same way that Gyroflow also uses Qt. That's what my first thought is, because there is a lot of good documentation around Qt. There's an experienced user base. We're more likely to find other developers who can also contribute to a UI, as opposed to the alternatives, which are new up and coming Rust GUIs, such as Slint is another one. But it's too new. This is the problem with it. It doesn't have a vast array of widgets that I might want to be using. It's got some basic stuff, but I don't think it's got all the things that we need. I don't think it's got all the things we need. But it is Rust. I'm going to look at this again before I decide one way or the other. I don't know yet. I need to try both of them and just look at the picture as we try and develop it. See what comes out. So Slint's one. A lot of other people use Egui. Some other people I know have been using Egui, include the lead developer of EmuFlight. He's using Egui in some things, and it's just amazing what a small world things are. It's just the circles of people, and it's funny. So there's Egui. I was looking for the widgets. It's got some widgets. It's not very many. What I don't want to be doing is making 1,000 widgets. I'm not in the business of writing widgets. That's not what I want to do. I want to write pick and place machine software. I don't want to write 1,000 widgets. I want to use a library that's already got loads of widgets. And that narrows down this choice of UI libraries greatly. So some of the UI widgets, some of the more complicated UI widgets that we're going to need are grid views. Sort of like if you think of Excel, for instance, where you've got a grid view and you've got things in it which you can click, edit, adjust, select, multiple selections, reorder columns, sort columns, all this kind of thing. This is the kind of stuff that we need. We don't just want like a button that says click me or a slider. You know, all the widget libraries do those things. We want some of the more involved things. One of the other things that we also want to do is display things like Gerber files and things like that. So we need support for certainly displaying SVGs. Probably you can convert Gerbers to SVGs, or I don't know, there probably is a Rust Gerber library. Look, there's one. And this is what I'm saying about the Rust ecosystem. If you search for it, and you'll find like a few. I don't know whether it's a Gerber viewer, but there might be a Gerber parsers, Gerber types. Yeah, so there's loads of stuff out there. Anyway, so displaying Gerbers. One of the things that I would also like to do, and this is a stretch goal, as they say on like things like Kickstarter and the like, is automated optical inspection. There, I said it. So who knows what an automated optical inspection machine looks like? Automated optical inspection. Because I'm thinking about, as I was saying, the big picture workflow for what a maker needs to do and the problems that you get doing this stuff. Let's look for machines. Right. An automated optical inspection machine looks extremely similar to a pick and place machine, but instead of having feeders and stuff on it, it basically has a camera. And you can they normally have like either one camera or multiple cameras, which take multiple images of the same thing using different colors. Let me see if I can find, a screenshot on here of what they create. Yeah. Here's one. So what this picture on the top right is an image taken from an AOI machine after it's used different colors of light to take the images with. So a pick and place machine already knows where all the parts are supposed to be, what the part looks like from the bottom, potentially what the part looks like from the top, if you tell it to, and all the dimensions of the part, and so on. So if you've already got half of this information, it doesn't seem like it's that much of a stretch to make the camera move over the part that it literally just placed, take a photo of it at that point in time, just after it's put the part down, and or do it later. With one or more head-mounted cameras which point from the side to look at the board before you reflow it, and then you reflow it, and then you put the same board back in the pick and place machine again, and you run the same process, and then you can see whether things have moved, you can see whether things have tombstoned, and so on. And then you can define a set of rules that say, this is what it looks like if it's good, and this is what it looks like if it's bad. And then instead of you having to manually take that machine, and put it under your microscope and hope that you've looked at it and spotted all the problems, you can get the machine to do a lot of the work for you, and ideally flag potential bits so that you can then come in and look at those. So being able to do automated optical inspection on this is a stretch goal of this. I'm not going to include it on this architecture thing, but you could probably fairly sort of easily see where it might come in, and that might be in the UI planning sort of thing. Yeah. So, yeah. So UIs. How did I get onto UIs for automated object inspection? Yeah. So UIs. Got a little bit sidetracked there. So UI needs to support a various bunch of different widgets, such as being able to do rendering of various photos, potentially rendering of videos, displaying certainly 2D things. The other thing I really love in this is toolpath visualization. So I don't know whether any of you are familiar with, what's it called? Oh, I just installed it yesterday and I've forgotten what it's called. Bear with me a moment. I haven't used it for a while. This is why my CNC machine is behind me right now. What's it called? Oh my god, I can't believe I forgot the name of it already. I'll find it. Hold on. Let me... oh, it's too many bits of software. Yeah, we get rid of this. No, not that. Bear with me a moment while I find this. I've got to look through my download history. What's it called? Not print run. UGS. UGS. Here we go. Yeah, couldn't remember the name of that for the life of me then. UGS. UGS. No. UGS. Here it is. Let me bring it up. UGS. Universal G-code sender. I don't know what this is written in, but it doesn't load up quickly. It's not like my machine is a slow machine. So let me make this a bit smaller. There we go. So let me just open this up. Cheese. Okay. Yeah. I'll just quickly stick something in on here. 1 second. Do I need to? Yeah, go on real quick. File, new design. Here we go. We're gonna draw some text that says the word MakerPnP. Wait, no. And we're gonna say on the path. And we're gonna put it down here. And we're gonna say save. We're gonna go text. Right. And I'm not familiar with this, but what I'd like to be able to do is look at where the head is going to go. I think you can see it on this a little bit, in that it shows you where this yellow line is. Yeah. What the tool path is going to, where the tool path is going to go, where the tool is going to go. I want this. There are a number of reasons why I want this in this software. Firstly, it makes you think about your machine at a sort of abstract level very clearly. You've got to go, well, what tools are there? You know, because you've got, on a pick and place machine, you've got nozzles basically. But there are other tools which people have on a pick and place machine, such as tool changers. and so on. So there can be multiple tool paths and multiple things that move around on a pick and place machine. Normally, mostly such a conveyor is another tool. For instance, if you've got a fancy machine like a Neoden 4, it has a circuit board which moves around in the bed of the machine, and essentially you could visualize that because your pick and place machine would want to be controlling that. So if you had a visualization of where the things were and where the tool was, and visualization of your panel as it sits in the machine, this would be excellent. Not only that, it means that you can write a more testable application which other people can work on without even having a pick and place machine on their desk. They can contribute to the pick and place machine system without having a pick and place machine system. So they might want to be able to try the software and add changes to it for whatever reason before they buy or build a machine. So that would be fantastic to actually have toolpath visualization in the software. So it's pretty high on my list having that. So again, widget libraries need to have support for 3D views and things like this. I probably should look at the source code for this UGS because it does lots of these things that we're just talking about. Yes, an interesting bit of software. So yeah, so that's UGS. Yeah, so toolpath visualization. It would make a more comprehensive bit of software for sure. Another thing that I would like to do is visualize safe zones. So on pick and place machines, you have essentially a 3D space on the machine, and the machine can crash into various things on that 3D space. Much like if you're doing a 3D printer and you've printed it, and then you bring the head down without removing your 3D object that it's just printed, the head is going to crash into the object that's there, right? So knowing where it's safe to move to is very important. A, for the safety of your machine, and B, so that you can make sure that everything is going to work and works before you try it on the machine. So some way of defining 3D representation of the machine at a simple level. It doesn't obviously need to be a complete proper 3D model of it, though people could do that if they wanted to, technically. So defining where the bed is, for instance, defining where your feeders are, defining the extents of where a head can move to with a nozzle retracted, knowing how far a nozzle can retract or is retracted. So for instance, if the nozzle is sticking down and you've got a feeder that's this high and you try and move the head over here, it's going to crash into it. But if the nozzle is over here, it clears it, right? So knowing where the edge of the feeder is, so that, and then also knowing where the head is and how extended the nozzle is, means you can decide whether you're going to have a collision before you even try and move the head into it. So properly mapping the safe zones, I think, is fairly high on my list of would-be nices. OpenPnP sort of has this concept of a safe zone, but my experience with OpenPnP and my machine was one where it is possible and very easy to make the drag pin solenoid's pin crash into anything on the head, and it's also very easy to make the machine crash into other items without retracting the nozzle. I don't want to be breaking nozzles. Nozzles are expensive. I don't want to be breaking solenoids. I don't want to be upsetting the calibration of the machine. So you want to avoid any crash scenario before it can possibly even occur. So big safety thing. Yeah. Okay. So yeah, 3D simulation. AOI. Another stretch goal of this project might even be 3D mapping of solder paste. I mean, because it's part of your workflow. So potentially what you could do is paste up a board and then use your same AOI optical inspection cameras to do photos of your solder paste. Even if it's for just recording what the paste was like and then recording serial numbers of boards so that you can go, well, if I give this to someone, I want to, and that customer then has a problem with it, I can then go back to all the photos of all the manufacturing files that the pick and place machine did for every part that it put on the board and what it was like before it had parts put on the board and what it was like after the board. I want to be able to, for the customer, give me a serial number, and then I look at what I made and what I sent them so that I can say, send it back, it was a dodgy one. Or, yeah, it was, or there's nothing wrong with that. I shipped it to you. Look, I've even got the photos and provide proof to PayPal for like claims disputes and things like that, which you get as a maker. Because some people buy a product and they don't understand how to use it properly. They think it's going to do something else, and they try and get their money back through processes, and then say it's your fault through processes which you then have to spend a lot of time contesting. So whatever ammunition I've got to help with dispute resolution or end user support, fantastic. That would be very, very useful. Yeah, problem areas. Problem areas. Problem areas. Here we go. OpenCV. So how do pick and place machines know what a part looks like? Well, what OpenPnP does, it uses OpenCV. OpenCV basically allows you to create a pipeline of things that happen. So, for instance, on a pick and place machine, the camera would take a photo of the bottom of a part when it's on a nozzle. It would then try and identify the extents of that part, where the pads were, the orientation of it, and so on. In order to do that, it needs specific lighting conditions, and it often needs to have various different filters applied, and such as grayscale conversion or chroma keying, or there's loads of different ways you can do it. Also, if you've got there was a discussion that came up fairly recently in the OpenPnP code base, in the OpenPnP discussion groups, was that if you've got a part that's got 3 pins on it, such as an SOT packages, I never remember the numbers. There's too many numbers. Images. Right, some of these SOT ones, like this one here. If you've got this SOT 23, top right on my screen, and you pick up this part, you want to know that you've picked it up and which way around it's orientated. And to know which way that is orientated, you need to look at the shiny pads of the bottom of the part and draw a triangle over it. And then once you've got a triangle, you can have a vector to know the rotation of that part. Once you know the rotation, you can apply a correction before you try and put the part on the pick and place machine. So OpenCV has functionalities for drawing triangles between 3 black dots, for instance, or white dots, after you've done some image processing. So OpenCV is likely what will be used for the vision side of things. And OpenCV Rust integration does exist, it turns out. There's Rust bindings for OpenCV. OpenCV Rust, which is nice. Oops, OpenCV. Search for the right thing. There we go. Right, OpenCV. And I don't know how popular this one is, but it seems to be fairly popular, which is good. 1 million downloads, more or less. People use it in their day jobs because you've got the Monday to Friday stats. So yeah, so it must work at some level. So hopefully it'll work for this project. So yeah, using OpenCV, but I'm an OpenCV noob. I've never used it before. My entire experience of it is about a month of fiddling around with pipelines in OpenCV, in OpenPnP, and that's it. But you know, it's the process is there. It's, you define a pipeline, and you can add inputs to it, which is the value for say like a threshold or whatever, and then you get an output from it, which is sometimes a set of coordinates and things like that. Which is fine. So yeah, OpenCV, Rust OpenCV. So problem areas. So it's going to be fun integrating that. Touchscreen UI in Qt. I don't know how well yet the Qt widgets lend themselves to being worked on with touchscreens. But having said that, knowing that Qt supports native-looking controls and runs on Android, and Android is a touchscreen primarily user interface, it's probably going to be fine. But I haven't delved into it too much, but it's probably going to be fine. Other Rust UI libraries, I don't think they have the focus for the touchscreen side of things that I want. Other things that I'm going to fail at. My math skills aren't great. I know I'm not good at it. Algebra makes my head go blah. You think as a vision-based learner that I'd be good at algebra. No, I'm really bad at it. It's not where my skills lie. So for a lot of complicated things like advanced motion control and all this kind of stuff, my head's going to explode a little bit. Now, back in the day, when Quake 3 came out, I did do some Quake 3 modding. So I'm not averse to the concept of, things like vectors and all this kind of motion over time and animations and all this kind of stuff. I have done this stuff, but not for a long time. So yeah, it's going to be that's going to be interesting. I'm definitely going to be slow there, but if I do enough of these other things, hopefully someone else will step in and improve the areas that I'm no good at, which is what I'm hoping is going to happen with this project. But we will see. We will see. Maybe I'll have to do it all, and maybe some of it's going to suck, but hopefully that won't happen. Yeah, complicated Rust stuff. Okay, so my experience with Rust is an interesting one. I skipped Hello World and just went with a preemptive task scheduler running on an embedded ARM Cortex M4 processor. And I was doing 2 years of embedded Rust development, which is different from doing normal Rust development, where you have threads. Oh, the luxury of a thread. And the luxuries of like infinite memory, amounts of memory, and fast processing and things like this. So there's loads of Rust APIs that I have absolutely zero exposure to, and I'm going to be fully dropping myself into the deep end with this project because I'm probably going to learn about these too late for some things and then want to go back and change things and go, oh, if only I knew about that at the start. I can see this coming a mile away. However, the only way I'm going to learn about them is by doing something. So I've got to start doing something and we'll see where we end up. But as I'm going, I'm hoping that other people seeing me fail at this stuff, I'm going to try and live stream as much of this as possible, seeing me fail at this and seeing me choose the wrong things, are going to type in a chat and go, no, you want to be using this. That's what I want to happen. So I'm going to hopefully learn from everybody else as I go through this. Yeah. So yeah, being a Rust noob. Yeah. I'm a Rust noob, but I know enough to be dangerous. That's been said before. Yeah. UI testing is going to be tricky. So one of my other requirements for any GUI library is testing support. I was happy to find that there are other people with similar mindsets to me in that regard in the Qt space, where you can create tests for your user interface. So I'm going to have a look into these and see how these work and what you can do with them. But the idea is that you don't necessarily want to test that your entire application is working, just that what's in a dialog box has the things that it's supposed to have in it. And that when you click one, it has an effect on the other thing, and some of this UI interaction. So for instance, if you've got two coupled widgets, for instance, and you change the slider on one, maybe it adjusts the maximum extent of another one, for instance, on some other slider. And you've got to make sure that coupled interaction works in UIs. It's very common in UIs to have related UI elements. Yeah, I think I've covered most of the things I wanted to talk about today. Let's have a quick look at the list of questions in the chats, the various different chats. See if I've missed anything. Yeah. I'll see if I can fix the problems with the OBS display. I think something's moved somewhere, yeah. Do that for the next stream. Can I get something like a bamboo LiDAR sensor? Yes, there's various different time of flight sensors and 3D mapping sensors for the solar pace mapping. Like I say, that is a stretch goal. But basically, as long as you've got a camera that you can attach to your head and you can get information from it, from the machine, yeah, the world's your oyster. But it's getting the data is one thing, doing something with it's another. Yeah. UI tool. Yeah, I don't think there's any more questions in the stream. Obviously, it's early days yet, so there's not even going to be that many people in the stream looking at it. Yeah. Okay. Well, I think that's about it. So I hope you enjoyed my little intro to this this project, and hopefully you'll follow along. There's Twitter account, so I'll hopefully be posting the event information. I'll probably try and get more regular with some of the events and stuff. I don't know yet. But I'll post on the Twitter, I'll post on Discord, and I'll try and schedule the things on YouTube and on, did I say Patreon already? Patreon, yeah. Underneath here at the moment, there's some links, so you can subscribe to everything there. And that's about it. And as all good YouTube videos have these days, they have all the presenters. They do this thing where they have like a little outro. So I came up with something. We'll test it on you guys. We'll see if you like it. It's only software. How hard can it be?